Lesson 14.5, writing trigonometric models. The goal of this lesson is to be able to write an equation using the sine or the cosine function when given data. This data could come in the form of a graph or even maybe just 2 points such as the minimum and maximum on some trigonometric curve. As we look at the first definition in this lesson, you see the word sinusoid. A sinusoid could represent either this equation using the sine or this equation using the cosine. We also see here different variables in each equation that we have seen before. We have A, the amplitude. We have K, the vertical shift. We have H, the horizontal shift. And don't forget that we determine our period by that expression 2 pi over b. So in most of these problems we're going to, from a graph, identify the period, and then we'll set that period that we find equal to 2 pi over b and solve for b to get this value of b in each equation. Don't forget also as we do this that the sine and cosine can really, they're really almost one and the same. One is just a horizontal shift of the other. So it will be possible to write each equation in terms of the other, although it will look a little bit different in the end. Let's take a look now at an example. We will do number 1. This is a guided practice example from your text, different from the worked out examples so that you have an additional resource for you. Directions are to write a function for the sinusoid. And remember, this could be the sine or the cosine. In number 1 then, we of course need to identify the amplitude. The amplitude, which is our value of A, we can simply find that by taking our maximum y value and the minimum y value and subtract them. So 2 minus a negative 2, and of course we want to divide by 2, because if we take the x-axis, which is considered the midline, the amplitude is the distance from the midline to either the maximum or the minimum. So we'll want to divide that by 2 to get the amplitude, which would be 4 over 2 or 2. So we found our value of A in the equation. You can pretty much see here that the midline is y equals 0. There will be no vertical shift. Remember, K is our vertical shift. And just to verify that it is 0, remember this midline is it's halfway between the maximum and minimum, right? We're trying to find the halfway point between those values. In other words, you should be thinking midpoint, and whenever you want the midpoint, you should add your endpoints and divide by 2, and you can see we're going to get 0 over 2, which is 0. There is no vertical shift as we suspected just by looking at the graph. Next, we want to identify the period. If we take this piece of the graph from here to here, you can see that is one full cycle of the cosine. One full cycle of the cosine, and that happens from 0 to 2 pi over 3. So the period is 2 pi over 3. Now, we know that we also get the period by dividing 2 pi by b, so that should be equal to 2 pi over 3. If we cross multiply, we're going to get 6 pi is equal to 2 pi b. We can divide both sides by 2 pi to get 3. So far we've identified the amplitude as 2, the vertical shift as 0, and our value of b as 3. In this portion of the graph from 0 to 2 pi over 3 that I've boxed in, we'll use that to write our equation. Of course, if we shifted that window a bit to the left, just about a unit, we could get the sine graph. But it doesn't matter which one you use, and in fact, if we did use the sine graph, we'd have to account for that horizontal shift to the left. So we're going to use the cosine, and the general form then is a cosine b x minus h plus k. Now we can substitute our values. We've determined a to be 2. Now there is no horizontal shift. H will be 0, and of course k is 0. There is our equation. For our next example, we'll look at number 2 from the guided practice. We are still doing the same thing. We are writing a function for the sinusoid. Again, this could be a sine or a cosine. What I'm thinking, though, is this. If we do cosine, an equation for one full cycle, it would be that window there. That would be a horizontal shift to the right of the basic cosine graph, and of course downward, it looks like. Now, what may seem a little easier to me is this window here, accounting for, well, that looks like the sine graph, doesn't it? And in fact, there is no horizontal shift. There's only a vertical shift downward. So I'm thinking it'll be a little less work to write this function in terms of the sine rather than the cosine. Let's begin now to find those constants in our equation. And as we mentioned, there will be no horizontal shift h. We should expect that to be 0. Let's first talk about the the amplitude. Remember, we are taking the maximum of 1 and the minimum of -3. We're subtracting them and taking half of that, so we're going to get an amplitude of 2. Let's box that in so we can identify it later. Next, we need to talk about the vertical shift k. Now remember, we can think of the midline. It looks to be right about there at -1, at y is equal to -1. But remember, that midline always occurs halfway between the max and the min. It's the midpoint. So we will add those endpoints, those y values that is, and divide by 2. So there is a shift downward of 1 unit of the basic sine graph. Next, let's talk about the period. we can see here that one full period of the sine graph, for example, if we start here at 0, one full period will happen from 0 to 2. So the period is 2. So what we can do is we know the period is obtained by dividing 2 pi by b, and we know that's 2. Cross multiply and divide by 2. So b is equal to pi. And I think that's about it. We don't see any, if we're going to use the sine rather than the cosine, there is no horizontal translation. So our equation will resort to y equals 2 sine of pi x minus 1. Let's next take a look at a problem that appears to be a little bit different. We are to do the same thing we did in the last two problems. We are to write a sinusoid function given these 2 points. We are given a maximum at point A and a minimum point at B. The first thing we want to do here is to sketch a basic graph of what we see. I'm going to pause the video to save a little bit of time, sketch this out, and we'll talk about it. Okay, here is a basic sketch, the axes y and x. I have plotted the points A and B. Notice also the scaling on the x-axis. We're given a maximum at pi over 3. Now, I didn't want that to happen exactly 1 unit on the scaling to the right of point B. So what I did is I took half of pi over 3, which would be pi over 6. So each unit on the scale would be pi over 6. So you can go 1 pi over 6, 2 pi over 6, 3, 4, 5 pi over 6, and so on. Because of the symmetry of a cosine or sine graph, the next point on this curve will happen. Notice that point A occurs 2 units to the right of point B. That means the next point to the right of A will happen 2 units to the right of A. So there is our next point. And what I'm thinking is, gee, this looks like a flipped cosine graph, doesn't it? So maybe something like this. That would be 1 full cycle, and it's flipped, right? Now, whenever it's flipped, our value of A will be less than 0. Let's go ahead now and proceed finding the amplitude. Let's find the vertical shift. And let's find the value of B. So you would have to now identify the period, and you could see our period would be 1 full cycle happens from 0 to 4 pi over 6. What I would like you to do now is find those values and then write the equation. And I will also work this out and we can check our answer. So after you're finished finding that, continue the video to find out the solution. You should have found that A is 1, and of course we talked about the cosine graph being flipped, so we're going to let it equal -1. The value of B is 3, found by that. The period is 2 pi over 3, set that equal to 2 pi over B to get that. No shift and horizontal shift, and then K is 4.